Welcome to this eLearn Security video training lesson on exploiting error-based SQL injections. The technique we will see exploits the verbosity of a database management system when managing errors. We will inject invalid commands on web application queries to extract information about the DBMS and the data it hosts. Keep in mind that error-based SQL injections aren't about how the web application prints errors. They just exploit how the DBMS manages incorrect functions calls. The page we are going to study uses the ID get parameter to retrieve product data from a database. We can test the parameter for injections by appending a single quote to the ID value. The application prints a SQL error, so it's vulnerable to SQL injections. Before actually exploiting the vulnerability, we have to reverse engineer the original query structure. The query is probably something like select some fields from products where ID equals ID get parameter. By reading the error printed by the web application, we can imagine that the ID value in the where statement is surrounded by parentheses. Let's inject one single quote parentheses, a semicolon, and a SQL comment to see if we can make the query work. The query still doesn't work. We can try to remove the single quote and see what happens. The query finally works. So we can say that the query probably looks like this. Select some fields from products where ID equals parentheses 1 parentheses. Now that we know the query structure, we can start injecting arbitrary queries that will trigger errors. This will make the application print those errors, thus printing the data we are looking for. As you studied in the course, the basic principle behind error-based injections is triggering a data type, or casting error. Let's start by converting a string into an integer. We can make the DBMS perform an implicit cast of a string to an integer by typing 1 or @ version equals 1. As you can see, the application prints a conversion failed error. The error description contains the data which can't be converted. In other words, the content of the @ version special field. The error tells us that the DBMS version is Microsoft SQL Server 2014, and that it's running on a Windows Server 2008 R2 machine. Let's use this to dig further and extract information about databases, users, and data hosted on the server. We can extract the database list by using the db_name function. Here we use the db_name to extract the current database name, which is USR management. Moreover, we can pass an integer index to the function and exploit it to list all the databases hosted on the server. 0 points at the current database. db_name1 reveals us the master database. 2 returns tempDB. 3 returns model. 4 is the index of the MSDB database. 5 returns employees, and so on. We have just seen that there are 9 databases on the server. Let's use a similar technique to list the users by exploiting the user_name function. Our payload is 1 or user_name 0 equals 1. The first username is public. The second is DBO. The third is guest, and so on. We can extract the username used by the web application by calling the user_name function without arguments. The application interacts with the database by authenticating itself as the DBO user. If we want to extract the output of a complex query, it's better to use the explicit cast technique you studied in the course material. For example, we can use the following payload to extract the database version: -1 or 1 in select top 1 cast of @version as VARCHAR 4096. Typing complex SQL injection payloads on the address bar of the browser is very prone to errors, so we will use wget, a command line utility. So we copy our latest payload, open a terminal shell, type wget, paste the URL surrounded by double quotes, and add the -Q -O command line switches. This tells wget to submit our payload and print the results on the standard output. If we hit enter, wget displays the DBMS version on the output. Now we have to just replace @version with whatever value we need and add the appropriate where clause. We already know the current database name is USR Management. Now we can extract the tables USR Management contains. Our payload has to cast each table name to string. And select the name from USR Management .sysObjects. Where xtype equals capital U. The name of the first table is clients. To extract the other tables, we have to filter clients out by appending to the query and name not in clients and send our request. The name of the second table is accounts. We continue filtering out results until we extract all the table names. As you can see, after filtering out the products table name, the web application doesn't print any error, but simply displays its normal output. This means that we found all the tables in the database. Let's take a note of the names. To continue our schema exfiltration, we need to know the name of the columns that make a table. The accounts table looks interesting. SQL Server References stores the column names in the special sysObjects table. In our case, we have to cast the USR Management .syscolumns.name field. From the table USR Management .syscolumns, USR Management .sysObjects. Where USR Management .syscolumns.id equals USR Management .sysobject.id and USR Management .sysobjects.name equals accounts. The first column we find is password. Let's filter it out by inserting in our payload and USR Management .syscolumns.name not in password. We find the username column. Let's filter this out. The table has just 2 columns. We are now ready for the final step, the data dumping phase. To dump the usernames, we have to just select and cast the username field from the usrmanagement.accounts table. The first user is the administrator user. Having a username without a password is useless, isn't it? So we concatenate the username, some pipe characters, and the password together. Here we can see the administrator's username and password pair. Now we filter the username out and resubmit the query. Reiterating the process, let us extract all the credentials in the database. Error-based SQL injections let us dump an entire database with just a web browser or a simple command line utility such as wget or curl. You will see how to automate this process in the SQL map videos. And this concludes this video. Thanks very much for joining us.